Hello students. So we are doing trigonometric functions. Let's see some graphs of these trigonometric functions, that is domain and range. Okay. So sine function, we have a graph like this. Okay. Whatever the value is, you have to plot the graph. Okay. Sine function is defined from r to -1 to 1. This is a closed interval. So its domain is R, set of real numbers, and range is -1 to 1. So you can see here that is for y-axis it is 0, 1 and -1, and x-axis you have to take all the values, that is in terms of pi. Okay. So sine 0 is 0, sine pi by 2 is 1, then sine pi is 0, sine 3 pi by 2 is again this is -1, 270, right? Then sine of 2 pi is 0. Also, it is for the negative angles, value remains same. Only thing is when you take sine of minus pi by 2, it will be minus. Okay. For sine of minus pi, it is 0. Sine of minus 3 pi by 2, it will be plus 1, because 3 pi by 2 it was -1. Here it will be minus plus 1. Okay, so this way you can draw the graph of sine function. Then we have a graph of, all the graphs are given here, graph of cos function. Okay, it is also defined on the same interval, domain and range. Okay. So it is also same as the sine function. Then we have a tan. Okay, for tan function we are removing multiples of pi by 2. Okay, because for, and these are odd numbers, right? Pi by 2, 3 pi by 2, 10 of pi by 2, that is 1090 is not defined. Okay, so the values which are not defined, the values for which we get a not defined number, we just remove them from the domain. Okay, and its range is R and its function is like this. Okay. Then for cot also we are removing the multiples of pi, okay, because the value goes to infinity. Same way it is for sec and cosec. So you have to see which values are going to infinity, those you have to remove. Okay. Next topic which we have is trigonometric functions of sum and difference of two angles. Okay. So these are actually the identities. Okay. We'll again draw the quadrants. So this is 0 to pi, pi by 2 which is 90, then pi which is 180, 270 is 3 pi by 2. Okay. So when you are taking angle from here to here, that is in anti-clockwise direction, it is positive, right? When you are taking angle in this direction, it is negative. So we count it as a negative angle. So then again we have something like all students take coffee. That is, all are positive in the first quadrant. Second quadrant, sine and cosec are positive. Rest all are negative. Tan and cot positive. Cot and cos and sec are positive. Okay. So if you have a number, say sine of minus theta. Now this we can write as sine of 0 minus theta. Right. So you are removing something from 0. So this is a negative angle. Correct? Negative angle, so you have to count from here. So it falls in the fourth quadrant. And for fourth quadrant, what is the sign of sine? Only cos and sec are positive in the fourth quadrant. Correct? So sign of sine here is negative. That's why we get this as sine minus sine theta. Theta is the angle. Okay. Same way, if you take cos of minus theta. Again, this is cos of 0 minus theta. So it falls in which quadrant? This quadrant, fourth quadrant, right? And okay, so theta here it has to be specified, that is theta um, ranging from 0 to pi by 2. It is between 0 to pi by 2, like that. Okay, it's not here, it's in the quadrant. So this is again a negative angle. It falls here in the fourth quadrant. We know that cos is positive here. So cos of this angle will be a positive number, cos of theta. Okay, so this way you can calculate all the angles which are given. Okay, so I'll take one example. Say sine of okay, sine of pi by 2 minus x. Okay, so now pi by 2 minus x. Pi by 2 is here. We are starting from this, correct? Pi by 2 minus x means this number, that is sine of this angle, falls here. Correct? It falls here. Now, one thing you should remember, that is there is a shortcut to write. Okay. Whenever you have 0 to pi and pi, we take transformations. That is, for pi and 2 pi, it is not transformation. For pi by 2 and 3 pi by 2, it is transformation. Okay. Here the cos and sine or all the trigonometric functions remain same. That is, you can note down that for pi by 2 and 3 pi by 2, we have to do transformations. That is, sine changes to cos or cos changes to sine. Tan changes to cot and sec changes to cosec. Okay. For pi and 2 pi, pi, 2 pi and 0, there is no transformation. No transformation. Means sine is going to remain sine only, cos is going to remain cos only. Okay. So using this, you can write sine of pi by 2 minus x. Okay. This falls in the first quadrant. So first you have to write the sign. It falls in the first quadrant, so it is positive. Okay. Now pi by 2 is there. Is there a transformation? Yes. Sine changes to cos. So you can write cos of x. Okay. Same way, if you have cos pi by 2 minus x, it will be sine of x. Okay. So this applies for every number. That is, if you go for say sine of 3 pi by 2 minus x. Okay. 3 pi by 2 minus x falls in which quadrant? 3 pi by 2 is here. Minus x means we are removing something. So it falls in the third quadrant. Third quadrant. What is the sign of sine? It is negative. Okay, and 3 pi by 2 is there. So transformation. So this is minus cos of x. Okay, this way you can find out any number. Let's take some pi and 2 pi values. If you have sine of pi minus x. Pi minus x. Pi is here. We are removing something. So you have to take this. Second quadrant. Transformation. First you have to write the sign. Sine of in second quadrant, sine of sine is plus. Transformation, no. So you have to write sine of x. Okay, this is a shortcut way to write any number. Take cos of 2 pi minus x. So cos of 2 pi minus x, 2 pi, you are removing something, so it falls here. So positive. Then transformation is there? No. So this is cos of x. Okay. What if you take plus x? So this falls in which quadrant? Fourth quadrant. Again, it is a positive sign. Fourth quadrant cos is positive and no transformation. Okay. Same way, if you take pi plus x, pi plus x, third quadrant, correct? In third quadrant, sign is negative and no transformation. Okay, so this way you can write. Then we have the identities. Okay. That is four identities are there. Addition of angles. Okay. Sin A plus B. So you have to write sin A cos B plus cos A sin B. Okay. Then sin A minus B. Sin A cos B minus cos A sin B. So everything remains same. Only thing is this positive changes to negative. Then we have cos A plus B. Here you have to take cos A cos B minus sin A sin B. Okay. So whenever there is plus, you have to put here negative. Again, everything remains same, but the sign changes. Here it is negative, here it will be positive. Cos A cos B sin A sin B. Okay, so you can use this to find, if I take sine of pi by 2 minus x. So you can treat this pi by 2 as A and x as B. So let's see what happens using this identity. Sine pi by 2 into cos x minus cos pi by 2 into sin x. Okay. So what is sin 90? 1. So this is cos of x. 1 into cos of x, cos of x. Cos 90 is 0. So this term is 0. So you get cos of x. Okay. So you can use both the methods. You can use these identities or you can use that shortcut method to find out the solution. Okay. So this is for sine, cos. Then we have for tan. Okay.